So in the previous lecture, we introduced interacting theory, and also we introduced interaction picture. Our goal is to compute the correlation function of time ordered product of Heisenberg operators. We said it in the previous lecture, where this is the vacuum of the full theory. Then in this lecture, this is our goal, and more importantly, we introduce this interaction picture evolution operators, which is given by a time ordered product of exponential minus I over h bar Tb to Ta, the interaction picture Hamiltonian dt, where hi of t is simply given by this interaction picture operator. So this is given by u0 inverse t comma t0 v, which is a time independent thing, u0 t comma t0. So this is the summary of the results we obtained in the previous lecture. And our goal is to compute this quantity. So in this lecture, we will show how these two things are connected. More importantly, we will show that is equal to limit t tends to 1 minus I epsilon times infinity 0 time ordered product of interaction picture operators, then the interaction picture evolution operator t comma minus t 0 over t comma minus t 0. So this we will prove in this lecture. Okay, where this is the ground state of the free theory, which we know exactly and we know how to compute, and these are the interaction picture operators. Okay, there is also an important assumption that we would like to mention. The assumption that the difference between the energy of the ground state and the first excited state is non-zero, which means the spectrum is not continuum around the ground state. The spectrum doesn't have any continuity around the ground state. So this is often called that the vacuum is gapped. Okay, so in order to do that, so we'll prove this identity, and this will be the important thing. I mean, this result we will be using again and again in this course to compute various physical things. Okay, so in order to do that, let's proceed one by one. So let's first write down the interaction picture operator. So for sake of simplicity, I said T0 equal to 0. Then the interaction picture operator OH at T, we know that this is given by U inverse, U is the full time evolution operator, U inverse O at 0, U T comma 0. But then using the decomposed form of this U, the full time evolution operator, this can be written as U inverse T comma 0, U0 T comma 0, O0, then again, sorry, there is an inverse, U T comma 0, UI T comma 0. And this quantity is again the interaction picture operator. This is same as UI inverse T comma 0, O I T UI T comma 0. So this relation then gives the relation between, so this is the relation between interaction picture operator and the Heisenberg picture operator. Okay, so let's now, for simplicity, let's now take some product of two operators which are time ordered. Then from this above equation we get this thing is same as UI inverse T1 comma 0, OI T1, UI T1 comma 0, UI inverse T2 comma 0, OI T2, UI T2 comma 0, which is same as UI inverse T1 comma 0, OI T1. This thing is same as UI T1 comma T2, OI T2, and then UI T2 comma 0. Okay, so this is like the interaction picture operator at T2, then the interaction picture evolution between T2 to T1, and then the interaction picture operator at T1. Okay, so let me just put bracket in this way. Then you understand that this simply means that if I take now n product of n operators, time ordered product of n operators, this will simply become ui. So by assumption t1 is dot 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 greater than tn. This will simply become ui t1 comma 0. So this is t1 comma 0. Then oi at t1 ui t1 comma t2 dot 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 ui tn minus 1 comma tn oi tn. This is inverse, and ui tn comma 0. Okay, so very good. So this is the, in general, this is the expressions. So this is the way the product of relation of time ordered product of n operators in the Heisenberg picture and interaction picture. Okay, now let's now go to this original expression and let's now look at this part. Focus on this part. So what we do is that, so let's first try to do that. So this is O, which is the free theory vacuum. Time ordered T1 OI T1 dot 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 Tn OI 0. Oh, sorry, I missed a part. Ui T minus T. There are two T's actually, so sorry for that confusion. And by choice, T is greater than mod T is greater than any of this time any of this time arguments. Okay, that's also another assumption. You will see that that's why that is important. Okay, so then this quantity is same as, by definition, so let's now choose t1 dot 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 greater than tn. Okay, let's choose a particular time, and then this thing is same as, the meaning of this thing is that this is same as uit comma t comma t1 oi t1 dot 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 oi tn ui tn minus t. Okay, now using this above expression, I mean, we can use this expression to write this product of the operators here in terms of the Heisenberg picture. So this thing can be then written as, this is same as 0 ui t to 0, important is t to 0, then Heisenberg picture operator OHT1 dot 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 OHTN, then UI 0 to minus T, this. Okay, now we insert here complete set of states of the interacting theory. So the way we do this is ui, sorry, uit comma 0, some interaction picture states sigma n, then OHT1 dot 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 OHTN, then sigma n tilde ui 0 0 minus t, this sum over n and n tilde. Okay. Now using this expression, using the expression of ui of t comma 0, using the expression of ui of t comma 0 in terms of u0 t comma 0 and ut comma 0, so you can write this. This expression simply becomes sum over 0 omega n and then also omega n tilde 0, so this coming from here, exponential minus I en plus en tilde minus 2 e naught 0 times t, and then sigma n oh t1 dot 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 oh tn sigma n tilde. Okay, so these are the energies of the full theory, and this is the energy of the free theory. Okay, so this is the expression. So this also means that if we do not insert any operator, then ut t minus, this simply becomes exponential sum over n exponential minus I en minus e0 0 2t 0 n mod square. Okay, so we have to now take the ratio of this quantity and this quantity, correct? So we have to take the ratio of these two quantities, and then we have to take, okay, so let's do that. So let's now try to compute limit t goes to 1 minus I infinity 0 time ordered oi t1 dot 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 oi tn ui t comma minus t 0 over 0 ui t comma minus t 0. This is same as, of course there is a limit, then sum over n and n tilde zero omega n tilde 0 exponential I en plus en tilde times t, then omega n product of operators. I mean, this derivation is very clearly written in the note, so you should refer there because I may miss a factor here. over some n hat exponential minus I n hat 2t 0 comma Now question is that we take this time into this small imaginary directions. So what will happen is that only the smallest value of en tilde and en hat survive. Everything else is exponentially small. So which means that in that limit both n tilde, n hat, all of them become the ground state. So then from this above formula, if all this become ground state, then this factor and this factor cancels, and the whole thing simply becomes omega 0, which is the ground state of the interacting theory, OT1 ... OI Tn omega 0. So this is our desired formula, and we proved it. Sorry, here is when we say that exponentially small and suppressed, we assumed in this state that any excited state has non-zero gap from vacuum. Okay, this is where this assumption goes in, and under this assumption you can show these things. This also means that this is not true if the spectrum is not grabbed. We'll come back to this issue later. This happens for the massless particles, but other than that, this is the thing that happens. Okay. So this is our this is a very important formula that we prove, and we will use it again and again. The formula is this thing. So in the next lecture we will give some examples and we will do some we will use it. I just want to mention some specialization. So now up to this point the discussion was very similar, general. I will just discuss what happens for local quantum field theory, various expressions, what happens for local quantum fields in said 3+1 dimension. So in case of local quantum field, the full Hamiltonian is basically given by some space integral of some Hamiltonian density. Okay, this means that the Dyson formula what happens to the Dyson formula? So let's look at the exponent. So the exponent was I h bar. So let's now focus on for the moment ui infinity to minus infinity, because that is what we will require here. We said here that the t goes to 1 minus I infinity. So this quantity is same as time ordered exponential minus I over h bar minus infinity to infinity hi of t dt. This was our general formula, but in this case this thing is same as minus I by h bar infinity to infinity dt, and then there are spatial integrals d3x, and then you have Hamiltonian density. This can be combinedly written as, this is same as exponential I by h bar d4x. I mean, you integrate over the full Minkowski space. H of x hat comma t. So this is what special happens for the local quantum fields in 3+1 dimension. But as we discussed, that time ordering is usually ambiguous for space-like separated point. We already discussed it in case of free theories. So then for the very similar logic that we have already discussed for free scalars, this implies that for space-like separated points, the Hamiltonian densities should commute. This follows from Lorentz invariance. Sorry, this is the interacting Hamiltonian densities. I'm sorry. And this is the requirement of causality for interacting theory. Okay, there is a long elaborate discussion in Weinberg. I encourage you to look at this. I just highlight this issue so that you are aware of it. And of course then you can also specialize, I mean for this local quantum field theory you can specialize what happens to this formula and everything for local operators. All this thing is given in the notes. But these are just simple generalization of the most general formula that we have derived for any generic quantum field theory, which has, for which we can do interaction pictures. Okay. So in the next lecture, we will use this formalism to kind of compute various correlators, and we will do some examples first to see how these things work.